Welcome everyone. On today's tutorial, we are going to look at some examples of some questions that we can solve on Surds. So this is the first question. Express the root of 32 plus 6 all over root 2 as a single Surd, and hence find the value of 7 all over root 2 times in brackets root 32 plus 6 all over root 2. Alright, so this question will first of all treat this. First of all, work with this. We're going to express this as a single Surd and then find its value. So, solution. This is root 32 plus 6 all over root 2. So I'm going to simplify this fraction. We all know that beneath every whole number there is always an over 1, which is still that whole number. So I can now multiply top and bottom by the square root of 2. So I have here square root of 2 times square root of 32. That's, remember our law of Surd, the first law. When you have two Surd in different brackets that will be multiplied, the answer is this, root 64. And then square root of 2 times 1 is still square root of 2. So this will be equal to root 64 all over root 2 plus 6 all over root 2. Okay, so this will be equal to, since the denominators here are the same, I'll just bring them as 1. So this will be equal to root 2 root 64 plus 6. And then the next thing I'm going to do, I'm going to find the square root of this 64, because 64 here is a perfect square. Square root of 64 give me 8 plus 6 all over root 2. 8 plus 6 is 14 all over root 2. And of course, the next thing I'm going to do is that I'm going to rationalize my denominator. When working in Surd, each time we have an irrational number in our denominator, we multiply top and bottom by that denominator so that it will cancel out. So this will be 14 times root 2 is 14 root 2, and root 2 times root 2, same Surd multiplies, will give us just the number without the radical. So we have just 2. So these are answer. 14 divided by 2 is 7. 7 root 2. So we've gotten our final answer. The next thing, I'm going to replace this whole expression here. I'm going to replace it with 7 root 2. So the part B of this solution will be 7 all over root 2 times 7 root 2. So since we have over 1 beneath here, this and this will cancel out. So we are left with 7 times 7, which is 49. Yeah, because when I have, just to explain it simple, to explain it in a more detailed way, when I have 7 all over root 2 times 7 root 2 all over 1, 7 times 7 is 49, with this root 2 at the back all over root 2. That's why I cancel them out and I'm left with 49. So the final answer is 49. In this example, we are asked to express 2 root 5 plus 5 root 2 all over 2 root 5 minus 5 root 2 in the form q plus r root s, where q, r, and s are rational numbers. That means q or r or s should be equal to numbers that can be expressed in the ratio of two numbers. Let's say a over b. Like we treated in the previous tutorial, we said the rational numbers are numbers that can be expressed as a ratio of two numbers, a over b, using it as an example. So let's solve this example. Solution. First thing we do is that we write down the question. That's the surd we have been given. And then we rationalize this surd. How do we rationalize it? We are going to multiply this surd by the conjugate of the denominator. This is the denominator. 2 root 5 minus 5 root 2. We are going to multiply it by the conjugate, and the conjugate is simply the same expression but different or opposite sign. So where we have minus is going to be plus, but every other thing remains the same, just the sign in the middle that changes. Alright, so I'm going to multiply the denominators and the numerators and the denominators together. So I have 2 root 5 times 2 root 5. That's the first thing I'll do here. 2 root 5 times 2 root 5. Okay, so 2 times 2 is 4. Root 5 times root 5 is 5, because according to the first rule of surd, when we have same surd multiplied under different roots, is still the same thing as them being multiplied under the same roots. And then 5 times 5 is 25. The square root of 25 is 5. So that's our answer, 5, and I wrote it down here. So that's it. So I have my first simplification as 4 times 5. So next I'm going to do this times this. That's 2 root 5 times 5 root 2. So same thing, 2 times 5 is 10. Root 5 times root 2. Root 5 times root 2 is going to be 5 times 2, and that's 10. Now root 10 is an irrational number, so I'll just write it here like that. Root 10. Root 10. So I have, remember there is a plus in front, plus 10 root 10. And then going to do this multiplied by this. This is just the normal algebraic simplification. So I have 5 root 2 times 2 root 5. That will still give us 5 times 2, 10. 2 times 5 root 10. Since there is a plus here and there is a plus here, still have 10 root 10. Then I'm going to multiply 5 root 2 times 5 root 2. So I have 5 root 2 times 5 root 2. 5 times 5 is 25. Root 2 times root 2 is just 2. So I have plus 25 times 2. Okay. Next, I work on my denominator. So I have 2 root 5 times 2 root 5. That's going to be 4 times 5, because 2 times 2 is 4, root 5 times root 5 is 5. Then I'm going to multiply 2 root 5 times 5 root 2. So that's going to be plus 2 times 5 is 10, 5 times 2 is 10. And then I'm going to multiply negative 5 root 2 times 2 root 5. So minus times plus is minus 5 times 2, 10. 2 times 5 is 10. And then the last step is minus 5 root 2 times 5 root 2. So minus times plus is minus 5 times 5, 25. Root 2 times root 2 is 2. So I'm going to have 4 times 5 is 20 plus 10 root 10 plus 10 root 10. They are similar surds, and when similar surds are added together, we add the front numbers in front of the roots. So 10 plus 10 is 20, and then we bring down the similar surd, and then plus 25 times 2 is 50, all over. 4 times 5 is 20. Now 10 root 10 minus 10 root 10 cancels out, so we are left with minus, and then 25 times 2 is 50. So this will be equal to 20 plus 50 is 70, then plus 20 root 10 all over 20 minus 50 is negative 30, and we simplified further. I have 70 all over root 30 plus 20 all over negative 30 root 10. Of course, these zeros will cancel out because 10 is a factor of which number. These zeros will cancel out also. So I'm left with just 7 all over minus 3 plus times minus is minus, so 2 all over 3 root 10. This is our final answer. So coming back to the question, we've made it to represent something like this: q plus r root s. We have q plus r root s, where q is equal to negative 7 over 3, r equal to negative 2 over 3, and s equal 10. S equal 10, or we can see 10 over 1, which is still 10. So we can see that we've finally expressed each of these numbers as rational numbers. They are ratios of two numbers, a over b. 7 can represent a, 3 can represent b. So these are our final answer. Thanks for watching.